My name is Tetsuo Kan. I'm working as an associate professor in the Department of Mechanical and Intelligent System Engineering. In my laboratory, we are developing new MEMS devices or sensors. MEMS means microelectromechanical systems, and that is based on semiconductor fabrication techniques. So MEMS technology provides us with very small size sensors, such as a force sensor or inertial sensors or photodetectors, and so on. In this MEMS field, we are focusing on new optical devices by combining MEMS and plasmonics. Plasmonics is a kind of optical oscillation of metal, nano, or microstructures. So if we introduce light illumination on the metal, nano, or microstructures, so there the oscillation happens on a metal surface. But most of the researchers have been detecting this resonance nature using huge optical microscopes. It should be noted that such a plasmonic is very sensitive to our external environment. So it is very fascinating phenomenon for sensing. But if we put such nanostructures on the top of the semiconductors, such as MEMS, so we can also electrically detect its oscillation as an electrical signal. So we no longer require huge optical setups, so we can minimize the plasmonic sensor within a very small chip size. So we are applying this basic technology for developing a new cost-effective photodetector or the new spectrometer or new chemical sensors and so on. So in order to make these structures, we are using microfabrication facilities in UEC. So we usually go to a clean room in the UEC to make nanolithography or photolithography to make such metal or metal nanostructures. And in addition to the microfabrication, optical simulation is also indispensable. So in order to get a very good resonant structure, we often perform optical simulation and find a very good resonant structure and think about what kind of fabrication process is required. So we call this recipe for the microfabrication. Then do the fabrication and the experiments. That's a life cycle of our research. So recently, we have succeeded in making a new, very small spectrometer based on the combination of the MEMS cantilever structures and gold grating on the surface of the cantilever. So the gold gratings generate the plasmonic resonance when the structures is illuminated by the light. So the plasmonic response can be measured as a photocurrent on the surface of the cantilever. Then we found that if the cantilever is biplated as like this, so the light is incident on the gold surface, then we can retrieve the spectrum information by calculating the relationship between the vibration angle and the photocurrent at each angle. So we think that this is the very small, one of the smallest spectrometer so far. So we are now applying this very small spectrometer into gas sensing, for example, in a room or in an automotive environment as new IoT sensors. So I think the combination of the MEMS and the plasmonic is very fascinating to get very good and versatile new sensors. So I want to continue exploring the MEMS and plasmonic new fields. Thank you very much.